Okay, why don't we get started? Welcome to the webinar on the philosophy behind effective alarm management. My name is Todd Stauffer. I am the Director of Alarm Management at Exida. During this feature presentation, you will be muted. If you have questions or comments, feel free to enter them into the questions box. We'll take a look at them at the end of the webinar and either try to answer them live at the end or answer them as part of the follow-up to this webinar. So a little bit of information about myself. I've been doing alarm management pretty much as a main job for almost 20 years now. Been a member of the ISA-18 committee and an editor and voting member since back before 2005. As part of the ISA-18 committee, we also do different things besides writing standards. We also create what's called technical reports. I was involved in the creation of a few of them, including being the co-chair on one on basic alarm design. My latest role is as a co-chair for a new standard on safety, process safety controls, alarms, and interlocks when they are used as protection layers, a standard that brings together the world of functional safety and alarm management. So a little bit about Exida, founded in 1999 to make the world a safer place. We focused initially on functional safety and then expanded into other areas that impact risk in a process plant, such as cybersecurity and alarm management. We have programs for certification of devices. So if you've ever worked with a safety instrumented system and put together equipment with a SIL rating, chances are Exida did that SIL assessment. We also have a certification process for people, which is very important for the functional safety life cycle. It's actually a requirement of that standard. We have a similar program, not quite as rigorous, for alarm management to help people develop and demonstrate competence there. We have a suite of software for safety system design for the entire life cycle, which is called Excellentia. And as part of that, we have a tool for alarm rationalization called SIL Alarm. We are partnered with several control system suppliers, including Rockwell, Emerson, and currently working with Siemens when it comes to alarm management. So we're going to talk about alarm philosophy. My goal is to make you great philosophers by the end of this webinar. So we're going to talk about what is an alarm philosophy, why you need one, what's supposed to be in it, what is the content, and we're going to deep dive into a couple of particular areas like alarm prioritization and classification. So we'll deep dive there. And then we're also going to talk about some lessons learned and kind of what are the keys to make this process successful and changing the paradigm for the way people do alarm management at a site. So we're going to talk about kind of tips and tricks and lessons learned. So first, a word about terminology. There are specific meanings behind words like shall and should in the standards themselves, and we're going to be talking about both the ISA and the IEC standards, more on what they are in a second. But we will strictly interpret the words shall and should according to a specific way. If we see the word shall, that means that that is a mandatory requirement, so you must do that. If you see the word should, that's a recommendation. So that applies for interpretation of what is in the standard. You should also apply it to when you put text in your alarm philosophy document and follow the same convention. If you use the word shall, that is something that you're committing to do. That's a requirement of your organization then to do that task. And if you were to be audited and it was found that you were not doing that, then that would be a potential finding. So we have to be very mindful of the terminology that we're using when we're creating a philosophy document. And when it comes to alarm management, we're focusing on 2 alarm management standards. The first is ISA 18.2, created in the USA in 2009 and updated in 2016. The second is the international version of it, called IEC 62682. That was led by the chair and co-chair of the ISA 18 committee, so it's very similar to ISA 18.2, and that's actually in its update and revision cycle right now. Now, the content between these standards is 90 to 95% identical. They have similar sets of requirements and recommendations. They both talk about the alarm management lifecycle and are structured based on that. So we see that here. And if we look at this lifecycle, we can see, I'm going to try and enable the pointer here, that one of the stages of the alarm management lifecycle is called philosophy, and it's at the top. It's the first one. So that's what we're going to talk about, how to create the philosophy document that essentially fulfills that stage of the alarm management lifecycle. If we want to conform or comply with the standards, let's talk about what that really means. So if you were to want to conform to both ISA and IEC, that would mean that you would execute all of the mandatory requirements. So any shall statements you would you would comply with. When it comes to the use of specific functionality, we will see that in the standards, there are certain functions that are required to be in the control system. And a good example is alarm shelving. It's a very important tool to help the operator. The capability is a requirement for the control system, but it's not required that you as an end user use it. So your philosophy is where you actually document what your intent is. Do you intend to use that functionality or not, and how? And specifically with alarm shelving, that's an area where we do need to do that. When it comes to the responsibility for complying with the standard, that does ultimately ride with the owner-operator of the system. So now let's talk about whether you actually need an alarm philosophy and what the guidance is in these standards about having one. So if you are a new system, let's say a greenfield plant, the expectation is that you would develop the philosophy drafted as a part of your project planning, and that you would have it defined and approved before you begin alarm rationalization. And you can see, again, looking at our screenshot of the alarm management lifecycle, that the philosophy is really one of the first main steps of getting into that lifecycle. For existing systems or brownfields, where you're doing a remediation project, so you're fixing alarm management issues, if there is no philosophy yet, then one of the first tasks would be the creation of the alarm philosophy. So if you notice, the word should is used in both cases related to having an alarm philosophy. So it's a recommendation that you would have one of these documents. In terms of getting started, and what you need to do to be ready to do a philosophy, if you're a brownfield existing system, I would recommend doing some initial benchmarking first, where you measure the actual alarm system performance, find out how many alarms you're getting, nuisance alarms, what are some of the different scenarios where the alarm system is not performing well, We'll also do some qualitative assessments with interviews of the operators, and that would give you a wealth of input on the shortcomings that are in the system right now that you would hope to solve by creation of the alarm philosophy document. So it's a good input to the philosophy creation process. And you can notice here in this 7-step process that the alarm philosophy is the second step, and it's really the overriding guidelines that drive the continuous improvement approach to the alarm management lifecycle. So we really can't enter into the alarm rationalization process without that alarm philosophy in place, because it provides the key rules and guidelines for how to do rationalization. Now we're going to talk about what should go into an alarm philosophy. And here we're going to see a little bit and talk a little bit about the evolution of the standards for alarm management. So standards define the what are the requirements. So here we have a list of the content that is supposed to be in the alarm philosophy. And you can see there are two different options. There are required content and recommended content, so shall and should. When the standard was first created by ISA in 2009, this is the set of requirements. When the IEC standard was first published, we added the alarm audit topic, something that you could say we sort of forgot in the first version. And then when the ISA standard was updated in 2016, we added a few more considerations, some of which we're going to talk about here today: alarm response procedures and alarm shelving. So now we are on to the update cycle for the IEC standard. Basically every 5 years, these standards need to go through a review and update cycle. So we're going through and reviewing the content here. So I would expect that to maintain consistency and to build on what's been developed so far, that the IEC standard would take on board everything that you see in the 2016 version, and then consider adding or modifying what's there. So that process is going on right now. One of the other things that this points out is, depending upon, if you have an existing philosophy, depending upon when you created it, you may have some gaps. If you created the philosophy before 2009, before the alarm management standard came out, then chances are you definitely have some gaps. There are some things like alarm classification that were not really practiced before the standard came out. Now, if you created it around the 2009 timeframe and followed what was in there at the time, you have a good starting point, but you may be missing some of these later topics that one should go back and potentially add. So for self-assessment of where you are, if you have an existing philosophy, this is a good table to help you gauge what you might be missing. Now, the standard defines the what. When it comes to how do you do things or how do you do it, that's what technical reports are for. So to help in the development of alarm philosophies and to provide guidelines and examples, there was a technical report created. And I had the pleasure of helping to write that document. It came out in 2018, and here you can see that for every one of those areas that needs to be defined, there is some examples and some guidance contained in this technical report. So it could be recommendations on how to do things. It could be examples that one could actually take and potentially plug into their own philosophy, but it is not a philosophy unto itself. It does not, you could not take this document and say, this is our philosophy. It's not designed to do that. It's designed to give you examples and things to think about when you're creating the philosophy yourself. So why do we want to create an alarm philosophy document in the first place? Well, to create an effective alarm management program that's able to maintain itself and sustain over time, that's what you need the philosophy for. It's really the framework or the blueprint for a successful program. It, particularly in areas like defining roles and responsibilities for what people in the plant, what roles need to do what things related to alarm management, that's how you create a program that runs on and continues to work even as people change and move to different positions within the organization or move on in their careers. So it's really critical if you want to create that continuous improvement outlook. It also helps to create a common understanding of alarm management amongst everyone that's touched by it. Alarm management is not rocket science. It doesn't appear to people like it is that challenging or that difficult. But if you do it incorrectly, you can cause a lot of problems for yourself. And that's sort of what we've gotten into, where people think they know what to do, but they don't really know the best practices, and they go down a path that leads them to trouble. So part of what we want to do in this process is educate people on a different way of doing things and codify that within the philosophy. We want to document the work practices that would be followed to drive consistency, talk about ways to solve your potential alarm management issues that you identified during benchmarking. The document would be useful if you were ever audited. It's recommended, I would say required, by ISA 18.2 and IEC 62682. And last but not least, if you go through the process of creating an alarm philosophy, it provides you the opportunity to change the way you do alarm management. It could be a significant paradigm shift in the way you operate the plant when it comes to alarms. So it is an opportunity to set the bar higher and to really drive for operational excellence. So you shouldn't take the creation of an alarm philosophy document lightly as just, oh my goodness, we got one more thing to do. It really is a tremendous opportunity to change how well your plant runs. So now let's talk about some of the particular topics that need to go into a philosophy. The first one we're going to look at is alarm prioritization. And here on the screen are the requirements for that from the ISA and IEC standards. So the alarm philosophy shall address how to do prioritization. So that means we must talk about how you will do alarm prioritization. And then it provides some recommendations on content that should be there or that should be considered. So let's dive into how we might do that for a given site or a given plant. So the definition and understanding of what priority is for is a key teaching point. People need to understand that the alarm priority is really a way to differentiate the relative importance of one alarm judged against another. It helps the operator know when there are multiple alarms, which one do I respond to first? Which one is more important to the business? And the way you assess that is typically based on some combination of evaluating how bad the consequences would be and how much time the operator has available, the allowable response time. So in our philosophy, we want to define our alarm priorities. It's not recommended to have any more than 3 or 4 different process alarm priorities. And we're shooting for a priority distribution where we have just a small fraction of the alarms at the highest priority, nominally 5%, and less at medium and more at medium and the majority at low. Now, when it comes to the naming conventions for priorities, in some control systems you have the ability to define that, and many of them you do not. It's hard-coded. If you do have the ability to define them yourself, you might want to think about whether the use of high and low for priority names is a good idea. because those are also used as alarm types. So that means you will have information displayed in the alarm summary where you have one column that says the alarm type is low. You'll have another column where it says the priority is high. In an upset, that can very easily get confused. So from a human factors point of view, if you can come up with different verbiage for that, it's probably a good idea. You also want to then define, how do we evaluate the consequence? How do we judge it? We'll define different impact areas or risk receptors, typically personnel safety. That could be for employees and for the public, environmental and financial. So we want to define what those categories are, and hopefully you don't have to define them yourself from scratch. Hopefully you have a corporate risk matrix that you can use as a starting point. And what we're after here is really this portion down here where it talks about how to assess or evaluate the consequences. So it has our impact areas, and as we go from left to right or right to left, the consequence decreases. Now, another part of this matrix is up top here, the likelihood and the risk. Well, that's not relevant for alarm prioritization. Likelihood or probability is not part of the prioritization methodology. We're only interested in the consequences down here. So ideally, we want to start with this because this is a reviewed and vetted matrix related to business impact and risk management that's likely been reviewed by legal, probably, as well as process safety, etc. Now, when we look at this, to make sure that it's going to work for alarm management, we might make a few changes. If we look at these worst case categories, we can see that the top three are differentiating between the number of fatalities that occur. So we go from 1 to 4 to 5 to 50 to greater than 50. Well, that's a level of granularity that we don't really need for alarm prioritization. Because number one, we should not have alarms that if you do not respond to them, it results in a fatality or could result in a fatality. There should always be other protection layers above the alarm that would activate to prevent that scenario from occurring. But even if that is valid or a potential situation to occur, I would imagine that a fatality, a consequence that could lead to a fatality, is going to be set to your highest priority in your system. And it doesn't actually matter whether it's 1 fatality, 5 fatalities, or 50 fatalities, they're all going to be the highest priority. So we can either knock off probably these top 2 categories or condense them into this one here. The other element of tailoring a PHA matrix for use with alarm management is we need to have some financial considerations. And in this one that we're looking at, we have safety, we have personnel safety, and we have environmental. We don't have a financial way of evaluating the potential consequence of an alarm. And what you typically find during rationalization is most of the consequences are financial related, either a cost to production or damage to equipment and assets. So we need that to make a complete matrix. So here's an example of a matrix that does, in fact, in this case, have some financial considerations. So other things that we need to consider. We need to make sure that the terminology is pretty understandable, that everybody would, it's unambiguous, that everybody would assess the consequence in the same fashion and come up with the same answer, ideally. We also need to make sure that it's understood that the consequences that are described in a given column should all be considered equivalent criticality. So that means we have up here fatality, and down here we have a financial loss of $500,000. If those are considered equivalent, we've just put a estimate of the value of human life, and it's not very high. So if we had an incident and someone was to lose their life, somebody could look at this, a lawyer could look at this and say, if that's your risk management approach, you as a company did not value human life very significantly. So you never want to take somebody else's matrix and use it as your own. This has to be developed and vetted internally within the company with consideration from safety and from legal. We also need to define some way of evaluating how much time the operator has to respond. We'll call that the allowable response time. And one way to think about it is either you need to drop everything that you're doing and respond to the alarm right away. You can say you finish up one task and then you need to do the response, or perhaps the alarm is not as urgent and actually allows you to even start a new task before you begin the response. Some kind of way to qualitatively estimate how much time the operator has to respond. And then we put a time management figure with those qualitative measurements, and we end up with a complete matrix that looks something like this, where we have our consequences on the top, evaluation of urgency and time to respond on the bottom, leading to the priority. Some other things to consider in this case, we might not want to allow, or we might want to note that we need to do something different if we end up with an alarm where the operator has less than 5 minutes to respond and they're doing that to prevent a fatality. That's not a good design case. So we would want to try to do something to add other layers of protection. Ideally, we want to ensure that there's sufficient urgency anytime an alarm occurs. So something that's got more than 30 minutes to respond, sometimes I've seen people treat that as a no alarm situation. Well, I'm not sure that's the right way to do it, because there is still going to be the consequence. So maybe it's a lower priority alarm, but there's still some potential that something is going to happen. So in some cases, we may try to change the design to push the alarm into something where the operator knows that they need to respond relatively quickly, or we may just say that the priorities for this band are the same as what's down here in this row that says prompt. So advisory and warning in this case. So now let's talk about alarm classes and alarm classification. So the alarm philosophy shall include the definition of the alarm classes. So you need to define what classes you're going to use. And when it comes to that definition, relevant information about these different characteristics should be part of that. So classification is really a process for assigning alarms to groups that have common sets of requirements for things like testing and training and MOC and reporting. So anything related to the management of the alarm. So this gets to the fact that not all alarms are created equal. Similar to passengers on a plane and the way airlines treat first class passengers differently than economy class. Same goes for alarms based on the alarm classification. So you may have alarms that are for safety purposes, like this one that we see here, which we'll talk about more in a second. And there are different safety categories that we might define. Or another use of classification would be alarms that relate to environmental, either to prevent an environmental release or to help prevent violation of an environmental permit. So there are, so one way to think about classification is it kind of indicates what is the main purpose of the alarm. What are you trying to do with it? So it allows you to differentiate of all the alarms in your system, which ones are there really for personnel safety, which ones are for environmental. And we're going to look at some examples that relate to alarms that we will say are LOPA listed. That means they're called out in a layer protection analysis. And one of the things we're also going to talk about is how does alarm classification show up in the control system? And here we have an example showing from a Rockwell control system where actually the alarm summary display has the ability to present the alarm class. And that's a parameter that can be filtered by. So it's native in the control system. Now there are different acceptable ways to interpret alarm classes and what they mean. The one that we have talked about is using categories that kind of directly relate to what the purpose of the alarm is. Is it for personnel safety or equipment reliability or product quality? That's the recommended approach, I would say. It is also acceptable, though, when you interpret what's written in the standard and in the technical report, to create classifications that relate to alarms that require training or alarms that require testing. And I have seen some alarm philosophy documents created that way. To me, personally, that second example is not the best way to do it. If you do it that way, you're really losing out on a lot of the potential benefit of defining the classification. And let's see what I'm talking about. But part of what we're striving to do is to define for our different classifications to identify the fact that they have different requirements when it comes to things like testing and training, and it's up to you to define what those associated requirements are. So one question that always comes up during an alarm philosophy development project that we work with will be testing and training. And the question is, so you mean I have to test every single alarm? So you mean the operator needs to be trained on every single alarm? Well, no, not necessarily. Ideally, you would do that based on classification, and you would set the frequency or need for those based on the classification, and you would do it in a way that balances the risk versus the amount of resources necessary. So now let's talk about highly managed alarms. Now this pertains to classification. So this is a continuation of the classification study or discussion. And the standard defines what they are to a limited degree, but it also helps direct the interpretation. And it says highly managed alarm classes, and I'll draw your attention to the fact that it's plural, are classes of alarms that require more administration and documentation than others. And then it provides some examples of how you might designate or determine that something is a highly managed alarm. So just like there's different interpretations of how to define classifications, there's also different interpretations as to what a highly managed alarm is and what that means. So highly managed alarm is an alarm that belongs to a class that has more requirements than your general alarm. An example would be a safety alarm or something that's there for personnel safety. So if we think about the alarm associated with this analyzer shed, if someone was to disable that alarm or change the alarm set point, then it's possible that somebody could walk into that shed when they shouldn't have, when that beacon should be going, the door closes and they may never come out. So that is a really critical alarm. You could potentially die if you misinterpret or you misrespond to that alarm. So that's one that we don't want people messing with. So we want to have strict control over changes to the configuration. We probably want to test it on a weekly, if not daily basis. You're not going to do that for every alarm, but here's an example of where that special alarm warrants that type of treatment. Now, one of the origins of the concept of highly managed alarms comes from the OSHA PSM regulation. And if you think about what OSHA PSM would likely require you to do for alarms that would be part of an OSHA PSM program, if you look at the list, we'll see it's pretty close to what we've defined here for highly managed alarms. Now, again, interpretation of what that means, there are different ways within industry that people have done that. Some people have interpreted highly managed alarm as a class unto itself. I believe that is not correct. It might be acceptable, but I don't believe that that is the intended way of what it was supposed to be for. It is supposed to be for designating of the classes that you have defined which one or ones should be treated as highly managed alarms. So if we have this particular grouping of alarm classes, which ones would be considered highly managed? And that's the appropriate way to apply that designator. Now, the significance of all this is there are significant amount of prescriptive requirements within the standards related to what you must do if something is a highly managed alarm. Here is an example just for what should be documented for the initial testing of the alarm. So it's some pretty significant stuff. And as I mentioned earlier, you can kind of trace this back to OSHA PSM and what you would need to do to conform with that regulation if you're envisioning an alarm being part of it. So in general, the standards don't have a lot of prescriptive requirements, but this is one scenario where they do. So the way you have these requirements on you or not is based on whether you designate your alarm classes as highly managed alarms, in which case the specific requirements that are in the standards you must follow. And those are requirements. Now, if you've defined classes the way that we talked about, you can get a lot of value in terms of what's happening and understanding what's happening in your operation. One of the ways to do that is when you're defining your KPIs, your performance evaluation metrics, to set class-specific metrics. So if we look at an example of a LOPA listed alarm class, so again, this is alarms that are being used as independent protection layers with a quantified level of risk reduction. So alarms that are used for that, and why might we want to analyze the performance of them? Well, if you can see in this layers of protection analysis or schematic, this operator response to an alarm is one of the first early layers of protection, and it hopefully takes the brunt of the activity to prevent the need for a demand on the safety system. But that is what will happen if this alarm fails to work. So being able to measure for our safety alarms, for our LOPA alarms, how many times they activated is an indicator of how many times your hazard got to this point in your process, which is pretty awesome information to have, and hopefully it's not a high number. It also gives you information about how well this layer of protection is actually working. If you're disabling that alarm, or it's being suppressed, or it's a nuisance alarm or a stale alarm for a significant portion of the time, then you've just reduced the potential reliability of that layer of protection and made it so that your safety system is about to be hit with a lot more demands than it would otherwise. So fantastic information that you can get. Continuing with that example of a LOPA listed alarm and our layer protection analysis, if we have a certain initiating frequency that was assumed in the design, the measurement of how often that alarm is occurring is a direct comparison to this number. So if we find that that alarm is going off once a month, that's a significantly more active event than what we assumed here. So we're not going to meet our target risk reduction if we have something that's occurring 1 or 2 orders of magnitude more frequently than we thought it was. We would also know then that based on how that alarm is performing itself and whether it's a nuisance alarm or a stale alarm, that the level of risk reduction that we assumed, in this case the probability of failure on demand, might be compromised and may not, or let's say it would not, provide the level of risk reduction that we're counting on. So from 2 points of view, our layer protection analysis would really need to be revisited and would be not correct. Now, if you define the classes in the way that we recommended or we just talked about, you can get the reports and things that we just mentioned. Now, in different control systems, the usage of the alarm class is different from one system to the next. Some have class as a very prevalent attribute that shows up within the alarm system. In some, it's an optional parameter that you can add after the fact. But here's an example from Emerson Delta V system where we see that the classification is actually shown in the alarm help, which is an alarm response procedure. It can be shown in an alarm summary display, so we can actually filter the alarm summary display based on class. So we could see, show me all my LOPA listed alarms that are active right now. Hopefully it's a very small list. And you can also run reports based on that category of alarms, that classification, to get those metrics that we talked about. So here's an example where if you define classes in the way we mentioned, you can get a lot of great information about performance just by using that within the DCS and the functionality that's provided. So now we're going to move on to alarm suppression. And how do we deal with scenarios where the alarm is not really working the way it needs to, and we have need to suppress it from the operator or hide it from the operator? And there's many different scenarios for this to occur. Some are listed here. We could have something that's in the process of being commissioned and is generating nuisance alarms. We could have a scenario where the underlying hardware, the transmitter, for example, is malfunctioning and needs maintenance, and it's creating alarms. And that maintenance could be available short-term, or it could be a long-term situation where you need to wait to the next turnaround 3 months away before it can be addressed. Those might be addressed in 2 different ways. Could be undergoing maintenance. There could be equipment that's not in use because of maintenance or is not needed for the process operation. And also operators being flooded with alarms and being able to deal with nuisance alarms. So when we help people create an alarm philosophy document, we actually have an exercise where we create these scenarios and first talk about how do you deal with it now? How do you deal with it today? And then we talk about the functionality that's available in the control system for alarm suppression. And then we go back through it and say, how could we do it differently? How could we do it better in the future, leveraging the capabilities that are built in to the control system? So for alarm suppression, that's the ability to hide an alarm from the operator when they don't need to see it. There's 3 different types of suppression defined. I won't go through them in gory detail, just mention that alarm shelving, which is one of the forms of suppression, is meant to be a tool for the operator to allow them to temporarily suppress an alarm for a fixed period of time. And that typically would be used when you have a nuisance alarm. So some alarm that the operator uses their judgment to say this alarm is impacting my ability to focus on other alarms. It is not relevant at this point in time. I want to remove it from my field of view, but I don't want to lose the fact that it's there. I want it to come back after a certain period of time. Now, both standards actually have set it up so that alarm shelving is required functionality of the control system. So what's necessary for you to do when you create a philosophy then is to talk about how you're going to use alarm shelving, whether you're going to use it or not, and if so, how are you going to use it? There are different types of alarm shelving, and alarm shelving is implemented differently from one control system to another. So this in particular is one of the examples that I think of where an alarm philosophy needs to be tailored to the functionality of the underlying control system. And if you don't know what that functionality is, your philosophy is not going to be able to address this as well as it could. More on that in a second. So if we're going to put alarm shelving in our philosophy, what do we need to think about? Well, shelving is a great tool to help the operator deal with alarm situations, but you probably don't want operators to be able to shelve every alarm. Maybe you only want them to be able to shelve low priority alarms or based on classification. So that's part of the thought process. What alarms can be shelved? What can't be shelved? How long can they be shelved for? Is there an authorization process required? Does the operator need to get authorization from a supervisor to be able to do it? Are they recording the reasons? As part of this, we would want to build into the operational work practice that the shelved alarm list is reviewed on shift change and talked about during that handover. And we also might want to document what action we expect of the operators when they're shelving an alarm. So we don't want shelving to become just something that we're doing to push off the resolution of whatever problem is underlying. We would want to say, okay, operators, if you're going to shelve alarms, you shelve, and then the next step is to write a maintenance work order or something like that that drives the correction of the problem. So those are the kind of things that you want to think about, as well as there's some more considerations here related to the use of interim alarms or some of the procedural elements related to the use of shelving. Now here a quick overview of some of the differences in functionality from representative control systems. Honeywell is one control system where it supports both shelving options for predefined reasons for shelving. There are certain bands of shelving time allowed for alarms, and operators can select that. They can document their rationale for shelving an alarm, and a shelved alarm shows up as represented within the HMI. So that's a certain level of functionality. Rockwell implements it quite differently. So here, instead of the shelving definition kind of taking place at the HMI, it's actually behind the scenes in the configuration. So each alarm has a checkbox to indicate whether it can be shelved or not. It also has a parameter to define what the maximum shelving time is. So you can really define on an alarm by alarm basis the shelving behavior. In a PCS7 system, there is a single shelving time that's system-wide, and it has a limit, a maximum of just less than 10 days. So it operates differently from what we just saw. It has two different lists, one that lists shelved alarms that are still active, and one that lists shelved alarms that have cleared. So that helps you know that when an alarm becomes unshelved, is it going to reappear on my alarm list or not? In a Yokogawa system, for example, you have both types of alarm shelving, but the maximum time an alarm can be shelved for is 24 hours. So every control system supports shelving in a different way. And if you don't understand that, I don't believe that you can flesh out the best way to use that functionality in your alarm philosophy. So now let's jump on to the last topic, I believe here, which is alarm response procedures, or alarm help, it's often called. So in the standards, alarm response procedures are required in that they shall be readily accessible to the operator as specified in the alarm philosophy. So you define how you're going to use alarm response procedures. It also talks about how they should be accessible and what type of information should be included, with a recommendation on the content that would be expected unless something different is defined in the alarm philosophy. So here's an example of an alarm response procedure for a Rockwell plant PAX system, where from the results of rationalization, we're able to present this information to the operator, and it's got some additional information that's not part of the required set, but adds additional benefit to the operator, potentially when it's displayed to them. Honeywell, again, implements it in a different way with different levels of information called different things, but certainly a lot of good information potentially for the operator to help them know how to respond to the alarm. Emerson in Delta V has a different implementation method in their alarm help, again, showing some of the key information. And this slide shows the linkage, or the purpose is to show the linkage between alarm rationalization and the creation of these alarm response procedures. What you will find is that the information that's needed for these alarm response procedures is what you talk about and document during rationalization. So to define that this is a needed alarm, we document the cause, consequence, corrective action. And that's exactly the stuff that you want to put into your alarm response procedures. So they really go together. In fact, I would not consider doing an alarm rationalization unless I thought about and knew how I was going to be able to make that information available to the operator. It's such a compelling benefit that I think the two should be treated together. And if you don't have a way to present that information to the operator, I wouldn't start with the rationalization yet. That's a personal opinion. But more and more control systems support the ability to present that information natively to the operator within the system itself. Here are some potential other requirements to include in a philosophy related to alarm response procedures. And when we help folks create a philosophy, we'll go through these and discuss whether they make sense for their operation or whether they need to be changed or modified. They all include the word shall. So one of the potential changes would be to change that to a should. One common pushback that we get is, you mean I'm going to have to create an alarm response procedure for every single alarm in my system? Well, no, actually not. If you define your requirement as for each rationalized alarm, you will create the alarm response procedure. If you do rationalization, then you have the information you need to create the alarm response procedure. Then it becomes a very doable task. And in that case, if you use the word shall, you're signing your organization up to do that. You're kind of setting the bar higher, but in a way that's probably achievable and probably in a direction that you really should go. So you're pushing the organization to do something that's a good thing. Some of these other requirements may or may not be useful, or may need to be modified or eliminated depending upon the way your operation works. So that was a look at some of the key content. Now we're going to look at some lessons learned when it relates to alarm philosophy development. How do we make this process work? So how do you know when you have a good philosophy? What does it look like? Well, it's adopted, well adopted, widely adopted, and understood by the key stakeholders. So operations, maintenance, design engineers, configuration engineers, project engineers. Hopefully they all understand how it impacts them and their role, and they are taking that into account in their jobs. It also needs to be supported by management. I probably wouldn't start this project unless you had support of management, because you are setting up a program that requires resources beyond yourself. So having management support for that is a key. You also want to make sure, I believe, in an alarm philosophy that you provide actionable guidelines. In some cases, there's generic terminology put into philosophies, and some of that is what you see in the ISA or IEC standards itself. In some cases, it might be appropriate. In other cases, I don't think it is. So what's an example? Well, we looked at the requirements for alarm prioritization, and it basically said you should talk about how you're going to prioritize alarms, typically based on evaluating the consequences and the allowable response time. So what if that's what our philosophy said? Prioritize alarms, consider prioritizing alarms based on consequences and allowable response time. And I've seen philosophies like that. Well, to me, that's insufficient. That's not enough detail for somebody to take that and actually execute the rationalization process successfully and repeatably. So to me, that's a failure. It might check the box that you have some content there, but in terms of actually driving a behavior or work process, it doesn't cut it. We also want to make sure that it's comprehensive, that it covers all the necessary areas, and that it's tailored to the different roles in the plant. So hopefully making it so that the people like operations that are impacted by it can clearly see and can clearly read and understand what requirements and what work processes impact them. It should be DCS agnostic, so a lot of it is best practice and boilerplate from an alarm management point of view, but then it also needs to be DCS specific. So some of the functionality for things like shelving and some of what you would call out in a philosophy, I believe, are going to depend on the specific functionality in the control system. I would estimate that 80 to 90% could be DCS agnostic, and 10 to 20 is DCS specific, but that would depend on the specific customer situation and the control system. Now, a word about the importance of training. As I mentioned earlier, most people have a preconceived notion of what alarm management is or the way to do it. And in many cases, they're actually wrong or slightly incorrect. And we have to think that that is why we got into the situation that we are. So if we want a difference, if we want things to be different in the future, if we just take a bunch of people with their current knowledge and understanding of alarm management and ask them to develop a new way of doing things, is there a likelihood that we're going to make it better? Probably not, without the training to say, okay, here are the best practices for alarm management, and here's why they make a difference, and here's why you should follow them. So it creates a new mindset. So as part of the creation of alarm philosophy, I think alarm management training is a key element, not only before for the people that help to create the philosophy, but certainly after, when you're rolling out the philosophy, training would be necessary to educate people on what's in the philosophy. So if you expect something different in the future, to get there, I believe that training of the people that are going to help you develop that philosophy is critical, because they need to understand the best practices. In a lot of cases, people will say, you know, a philosophy is something that I could develop myself. I could go sit off in a room for a week or two and create that document and then send that out as something that should be followed. Well, what we found is that's not a very effective way to do it. And one of the reasons is it struggles when it comes to adoption, because you don't have buy-in from the other organizations. One of the keys to make this work successfully is, as part of the training and the philosophy development, that you have the key stakeholders involved in that. So they are learning the best practices. They are thinking about how it applies to their job. They are providing input to the philosophy in ways that will make their job better or their colleagues' job better or improve things. So once you've done that, you are much more likely to get support from those organizations when that document is rolled out, because they not only took part in the creation of it, they contributed to it as well. So it really does take a cross-functional team to create an effective document, even though you as a single person might know everything that should go into that document. Without the participation of other groups, it's very likely not going to be adopted to the level that you would like. So you can see the list of the key stakeholders shown in this slide. Plant management might be involved for part of the time, not the whole time, but certainly operations, control system engineers, process engineers, supervision, safety, all key people to take part and drive the content. We also often get questions about, what should this document look like? How do I structure it? We have the list of required topics on the left. So that's what must be in the philosophy. And I've seen some people that have created their philosophy where that is then the table of contents, and those are the topics. Well, I think that is not the best way to do it. That leaves out a lot of things. And what is a better approach is to generically set the structure based on the alarm management lifecycle. So you could think of it as, there's a clause maybe, or a section for each stage of the life cycle. Maybe some of them are grouped together, but then within each of those, wherever these particular sections would fall, you include them in the document and the table of contents. So that way you have a structure that follows the alarm management life cycle and is traceable to the requirements of the standard in terms of what should be in that document. How do I know that I have everything covered that I need to? Well, the ISA and IEC standards define the requirements and recommendations for what needs to be there. So you could compare your philosophy to what's in the standard, what it calls for. There's 27 sections, I believe, or 27 topics. And in each of those topics, there are specific requirements and recommendations called out. So that would be one starting point. Now, if you do that, you also need to make sure that you capture the requirements that are in other sections of the standard, such as here's some that show up in basic alarm design that actually drive what's supposed to be in your philosophy. So if you're doing a complete audit against the requirements, it's not just the clause on philosophy that you need to look at. And that's something that we can do, and we often do to help people, is to do an audit of their alarm philosophy and actually create a gap analysis document or assessment identifying what's missing and what could be improved. How long should the alarm philosophy document be? This is a question that often comes up, and I've heard comments and such that indicate that we want the alarm philosophy to be short. For example, if the document is longer than 10 or 12 pages, my colleagues won't read it. I've heard that statement before. Well, if we look at what the philosophy is supposed to do, it's really setting the framework for alarm management and all of the life cycle stages. I don't believe that you can address all of that required content to the degree that's useful and is necessary in a 10-page document. So there's a disparity there. Now, there are possible ways to address the problem with having to read a 50 or 60-page document. One way would be to break it up into multiple documents, one that's more of a design guideline versus a philosophy. Another way would be to have a high-level philosophy and then have other documents that go into the details. Recommendations could be put in an appendix, or you could put a section at the beginning of the philosophy that says, depending upon your role, like I'm an operator, what are the important sections for me to read and understand and that impact my job? So that basically takes a 50 or 60-page document and hopefully allows it to be easily filtered for the different roles that need to review it and digest it. This is an interesting topic and one that one of my colleagues just wrote a blog on. So if you want to learn more, please feel free to check that out. Now, what does exida do, or how do we help people create alarm philosophies? We have a program that we've executed many, many times for greenfield scenarios, brownfield, all kinds of different control systems, you name it. But what it starts with is initially some benchmarking or some operator interviews potentially to identify maybe what some of the systematic issues are, or you may already know them. And we skip that step, and then we start with a one-day alarm management training class. So basically the practices and principles for ISA 18.2 as applied to your control system. We've created the training so it's tailored to talk about the alarm management functionality in your control system, because that's a key part of this. That training also helps to get everybody on the same page in terms of best practices and setting the vision in the same direction. Then after that, 2 more days, which is the facilitated workshop to walk through the potential content that should be in your philosophy. And we don't start with a clean sheet of paper. We actually have a complete template that we work with, which is a complete alarm philosophy with everything but the kitchen sink in it. Actually, it has the kitchen sink as well. And what we'll do is we'll walk through that and take a look at what's there and see whether it makes sense to adopt for your philosophy what's written, whether it needs to be modified, changed, deleted, etc. So we'll find that some of the content can be accepted as is, like the definition of an alarm and the criteria, but other content like the priority matrix will be unique to your company or site. And that requires a lot of specific discussion to make sure it's appropriate. So the combination of the two allows us to get through that discussion in about 2 days. We would leave with that information, complete the update of the philosophy template, and send that back within a week. So we try to minimize the amount of pain or resource usage by making it so that you don't need to have dedicated resources involved for any more than those three days. And even that I know can be quite an ask at times as well. But it addresses some of the things that we talked about, which are key to make this successful. Trains everybody on best practices, sets the vision for a new paradigm, and starts to create buy-in and gets contribution from all the key stakeholders. So everything necessary to hopefully make that a successful venture. Our alarm philosophy template has been built from the ISA standard and other guidelines and recommendations on alarm management, including all of the great content that's in the ISA technical reports, as well as examples from industry. And it continues to evolve to include new ways of doing things and new scenarios. This is an example of what the content looks like. It's got explanations of what's supposed to go in each section, and then the representative text and which points need to be reviewed or discussed. So we're reaching the end here, and I apologize for going longer than what you might have expected. But for more information, direct you to the Exida website. Under Alarm Management Services, we have a section on alarm philosophy, and under there's a place where you can download that alarm philosophy template, or you could send me an email to have that sent to you. It's not the complete template, it's the table of contents and some representative sections so that you can see what it looks like. With us all sheltering in place, certainly we're going to be doing a lot more things remotely. And one of the things that you may want to do is up your alarm management knowledge. And one great way to do that is with online on-demand training. And we have a new course that's a 1.5-day class. We are giving it in Baton Rouge coming up the end of April, at least that is the plan. But we also have that available online on demand and live online as well. It also provides the ability to take an exam. If you pass, then we grant you the credentials to say that you are an alarm management practitioner. So it provides some level of acknowledgement of the skills that you've demonstrated. So now we're gonna switch and talk about whether you have any questions. I'll say thank you in advance for attending and listening. Again, I apologize for the length of this webinar. If you enjoyed this discussion of alarm management or are interested in learning more about alarm management, then I would encourage you to check out the other webinars that we've done previously and that are available on our YouTube channel. So let's see whether there are any questions. There is a couple of specific questions. I think the best way would be to take these offline and they'll be answered, and then you'll all get to see a copy of what the question was and the answer as well. So then that draws us to the end. So again, I want to say thank you very much for attending. I hope you found this useful, and please consider checking out other webinars in the future. Thanks, have a good day, and stay safe.